right, oh, I should have the screen. So that's the one on the right, looks like that. So I'm going to graph it. And the easiest way I find to graph it is to put in the dotted lines. And then from here, there's kind of this point and this point, oops, this pointer on the graph. I kind of do this part out that way. And then I kind of start from the point again, and I kind of go this point out, that way. So it's kind of the easiest way for me to graph it. Is to start at that point and kind of swoop it off that way. It's just, easier. Okay, so now we've done those. What do you know about the graphs of these two functions? I don't know. They both had those dotted lines that they can't touch. That's what I noticed. I never know they're going for these. I didn't write them. Okay, good. So then we talked about the fact that, like I said before with my t-shirt, you can never, ever, ever, what? Divide by zero. So whatever this is, when you're dividing with something that has x in it, then you have the possibility of the denominator being 0. So it means that this bottom cannot be 0. Right? Not x. X could be 0 here, but x minus 2 can't be 0. Is everyone looking up? See that? Yeah. X minus 2 can't be 0. So here, x minus 2 cannot be 0. So how do I solve that for x? I add 2 to both sides. So I'm kind of understanding what I'm doing to get rid of that minus 2. So x can't be 2. How about this one over here? What can't be 0?
X plus 1.
Deja, what can't be 0?
I'm not sure.
You're fine?
Negative 1?
X, so this bottom part, x plus 1 can't be 0. That's all I'm going for. It's whatever's below here. X plus 1 cannot be 0. Does everyone understand what I'm saying? Because then you're going to, if x plus 1, if this is 0, then you're dividing by 0. That's trouble. So whatever's here cannot be 0. All right? For this one over here, what can't be 0 over here? X minus 2. David, what can't be 0 over here?
2.
X minus 2 can't be 0. So x minus 2 can't be 0. 2 is never 0, right? But x minus 2 can't be 0. So then we can figure out that x can't be 2. What can x not be over here? I want to find what x cannot be. Solve that. What x cannot be. X can't be what? How to get x by itself on the left side? Subtract 1 from both sides. So if I take 0, subtract 1, what do I get? Negative 1. Is everybody kind of understanding this with me? If x is negative 1, negative 1 plus 1 is 0, and this cannot be 0. So that can't happen. So x is not allowed to be negative 1. Because if it was, we divided by 0, the whole world would blow up. Terrible. Okay. Okay, so yeah, so now let's look at our graphs. Where do the breaks occur? X can't be 2 in the first one, and x can't be negative 1 in the second one. Oh, whoops. Right, so you'll see x can't be 2. Does everyone see this right here? That's the first one, and x can't be negative 1 in the second one. Are you following me?
Yeah.
That's what x is never. That's how you find the domain. It's very easy, super straightforward. So in other words, to find the domain of a rational function, take the denominator that has x in it, set it equal to 0. Or just say, or you can just say x, say that it can't equal 0. And just solve for x. That's what I would say. That's the easiest thing, I think. Right, and you can either express it this way, x can't be 2, or you could say it goes from negative infinity to 2, can't touch 2, and then it goes from 2 to positive infinity. You can express it either way. These are the same. Because this means negative infinity to positive infinity except for 2. Alright, so now you all are going to do some exercises. I will put these up on the screen for you so you can see them. And I'll put breaks in there as well. So you're going to be doing number 1, and you're going to be doing number 2. So the first one is 2x over x plus 3. And the second one is 1 over x squared. Okay. So here they are. I'm going to change this to be solid colored. So the two solid colored ones, the red one is the first one, the green one is the second one. I'll move that over so it matches up with that. So I'll do the blue dotted lines. I'll do the red. I'll make this red.
The green one has a parabola in
Miss Allen's just 1.
The green one is just 1, not 21.
The green one is F2.
Yeah, it's not 21.
Oh, it's not 21. It's just 1. My bad. Oh, that's why it's weird. Okay. Is that better? I don't know which one's better. So here's the dotted lines for the I'll do the 2 red dotted lines. So the red one has the red dotted lines? Or is orange better? Maybe orange is better. Is it orange dotted line? That's too many colors. Maybe red dotted lines. And the green one has got dotted lines at 2, -2. And I see those 2. Should I put them on one at a time? Is it too confusing if I have them both on at once?
There's a third dotted line in the green too,
Yeah,
right?
it goes across the middle.
Yeah.
Yeah, I just can't show them. I think if I show that, it's going to be, well, I'll try. Yeah, I can do that. Yeah. So there's the first one. That's at -3, it looks like, and it y equals 2. X is -3 and y is 2. I'll zoom that one in a little bit.
So are we gonna be using this graphing software on the test to?
No, you're not going to graph these on the test. This is just the second one. We'll take a look at the second one. What's the question? What's the domain? Are there any breaks? What is x allowed to be? Where are my breaks for x? We'll do the first one first. It's easier. It's fine. Where are the breaks? Where's the break for x? What is x not allowed to be?
Oh, it's not -3.
Yeah, -3. Everybody see that one? So what's your domain? Write in your domain. X is not allowed to be what?
Y is not allowed to be 2.
Yep.
So you can just
So
write
first one,
the shortcut
is-
version?
x cannot be -3. Everybody got that part? What's the other break? What's the other breaks? The breaks are at x equals -3. Where's the other break at? Where's the other break at?
2.
What's 2?
Y.
Y. Y is 2. Can everyone see this line here? So the other break is at y equals 2. How's our bridge to the domain? Right? So x equals -3 is the break. That's the line that x can't touch. Right? So the domain is x can't be -3 because that's the line it can't touch. That's the one you're getting closer and closer to and you can't touch. X equals -3. Okay, so we're going to do it again with this one here. What can x not be? That's your domain. So what can x not be, folks?
-2 or 2.
-2 and 2? Yep. X can't be -2 or 2. And where are my breaks? Well, definitely had some breaks at x equals -2. And another break at x equals 2. And where's my last break? It's the y break. Y equals what? The horizontal one, y equals what?
0.
0. All right, because here, all along here, y is 0. As I go through, see as I slide, can anyone see that?
Yeah.
As I slide along here, what stays at 0?
Y.
Y. My x changes, my y is always 0 along here. So that's the easiest way to figure out whether it's y equals 0 or x equals, you all know it's something equals 0. Is everyone with me? Question is it x or y? Pick 2 points along here and see, okay, this point is 1, 0. This point over here is, sorry, this is -1, 0. This is +1, 0. So what stays the same? Y. Y is 0. So that's the easiest way to do it, is just to graph 2 points, pick 2 points on the line, figure out what their coordinates are. Over here I'd say, okay, I pick this point here, -2, 2, and -2, 0. What stays the same? X. X is -2 in both those spots. So that x is -2. Doesn't have to be on a graphing calculator. You can do it on just on your graph itself. Right, like I could do it on this graph here. I could say, oh, let me pick 2 spots. I'm going to pick this spot here. This is -1, 2. I'm going to pick this spot here. This is -1, -2. What stays the same? X. X is -1 in both of those. So x can't be So this line is x is negative 1. That's what the line is. All right. Next. Oh, we got more. So let me graph these. There's the first one. What can x, doesn't look like there's anything x can't be, does it? But what do you think x can't be? Ever look at your number 3. Looking at the bottom, find what you think x can't be. Right here, number 3. What do you think x can't be? What can you never, ever, ever do? Divide by 0. So, what would make that 0 on the bottom if x was what?
Negative 1?
Okay, let's solve it. X plus 1 can't be 0. Everybody do that. Take whatever's here underneath, say it can't equal 0, and then solve for it. Do it. Do it for the number 4 as well. Do it for both of them, and then we're going to check these out. So the first one is going to be, I didn't realize, I just realized you can't take, that's a negative 1. So we have x plus 1 can't equal 0, so then x can't equal negative 1.
Yeah.
The next one is x squared plus 1 can't equal 0, but then that means that if I subtract 1 from both sides, I'll get x squared can't equal negative 1. We can never, ever, ever take square root of a negative number, so we can't square root both sides. So here, when is x squared ever equal to negative 1? Never. So we're fine. There's nothing that x can't equal. Does that make sense?
Thank you.
So we're good with this one. Does that make sense for folks? So this one we're actually okay. So the top one, there should be an issue at x, where x is what? The first one, where should I have an asymptote? Or where should I have a spot where x can't, what can x not be?
Cannot be negative 1.
Can't be negative 1. Okay. So let's take a look at our thing here. Sure looks straight to me, right? See what I'm saying? I don't see any breaks here.
Yeah.
But I'm going to slide along here. When I get to negative, x can't be negative 1? Do you see that little hole? Can anyone see that?
Ah,
Yes, no? Here, I'll try to make it bigger.
yeah.
Does everyone see that?
Mhm.
At negative 1, it's undefined. There's a hole there. But it's infinitely small, so it's just at that one spot. If I go a little bit this way, put 0.96, then all of a sudden there is something there. If I go slightly the other way, negative 0.102, then it exists there. It's just at that one spot where it's undefined. So that matches up. I expected there to be an asymptote, but there wasn't. So that's kind of, that's not an line thing. We'll talk about that in a moment. So I would say the graph is now no. I expected a bigger break. Dotted line, kind of in a way. But there is a hole, is a break. But you can say whatever you want. I mean, you can say, yeah, it matched what you thought. It's just small. Hard to see. Okay, and then the other one was
What
to,
are we supposed to expect?
I don't know. I expected when I had when I had x can equal -1, I thought I was expecting a dotted line at -1 was what I was expecting.
I didn't know what to expect.
So then you folks are fine, because you had no expectations.
If you really zoomed in on that last one with the lines
It would never-
like this,
It would never do that because
would there be a break?
it's
That's one?
infinitely small.
Okay, so you can never
So-
zoom in enough to see the
No,
break.
you're never gonna be able to zoom in enough to see it. So as you slide along there, see it's negative 0.998, negative 0.9984, negative 0.999. And then it gets there, you know what I mean?
Yeah.
So it's so small that you can't, 1.0003, it's infinitely small. So that's the problem. So you only see it right there. If you go like 3/10,000ths in one direction or the other, so you can't see it. Okay, let's take a look at this one here. Ooh, this is weird looking, isn't it? So, yeah, I don't know, I didn't know what to expect with this one. So, right. Is this what I expected? I have no, so I'd say no, because I didn't know what to expect. Huh? No, didn't know what to expect.
What number is this?
Number 4. That's just weird. I've never seen anything like this, right? It's a strange one. It looks weird. Does it appear to be any breaks in the graph? There are no breaks in the graph. Just slide along here. How does the graph relate to the domain? No breaks. So that matches the domain. What's my domain? What is my domain for this one? There's nothing it can't equal. What's my domain? What can x be? What's the furthest left x can go? What's the furthest left x can go?
Okay.
So is it all no
Negative
numbers?
infinity.
Yeah, all numbers, negative infinity, positive infinity. There are no breaks. There's nothing x can't be. Good. All right. All right, so asymptotes. So the examples above show that in some cases there are values of x that make a rational function undefined. They're excluded from the domain and may cause breaks in the graph. So for example, the first one we saw, f of x equals 1 over x, excludes the value x equals 0. Right, x can't equal 0. That's the first one we found. So what we call that is that dotted line that it gets closer and closer to and can never, never, ever touch. We call that an asymptote. So that dotted line that you get closer and closer to that you can never, ever, ever touch from the first, take a look at the first one. Right? These are asymptotes. Everybody all right with that? Say the word asymptote.
Asymptote?
Asymptote. Like I am, it's a YM. Asymptote. Everyone say it again? Asymptote? Okay, good. Just get used to saying it, because it's gonna come a lot. Perfect. Range. The range is a lot more difficult. We're not going to deal with ranges in this class, unless it's a graph. So a graph, I might actually give it to you as a graph, right? So here, find the range. So the range is my y's. What's the furthest down it goes? Can anyone see this?
Negative infinity?
Negative infinity. What's the highest it goes? Infinity, but what can it not equal? What can my y, my height never equal?
Oh, 1.
1. So here, this is, the range is y cannot equal 1. And the same with the domain. This means it can be everything else, any other real number except for 1. I think it's a good time for a break. Let's take a break until 12:30, and we'll come back.